Hey everyone, Chang here and welcome to my channel. Now in a previous video, I tried my best to relate a basically very easy formula that you can memorize and how it can actually be used to create or relate to even more complicated formula. The one I'm thinking about is the Pythagorean theorem, a squared plus b squared equals c squared, and how that created the distance formula. Right? The distance formula is a little more complicated, but if you're so inclined, you can actually still memorize it. I'm going to stretch the relation even further. Now with the distance formula, I'm going to relate it to this. This is a circle, which hopefully you guys can tell, even though it's poorly drawn, right? And the idea is that here we have a circle and this is the center point. Now I'm going to use the coordinate h comma k, just because in the generalized formula of a circle, they use h and k, so I'm going to keep it at that so that it's not as confusing when you see the formula of a circle. So just remember, h and k, it doesn't matter. It's just the coordinate of the center point of the circle. That's all. Now, before we talk about the formula, we have to remember the distance formula. The distance formula is fairly simple. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, and if you guys are not familiar with the distance formula, that's entirely fine. I made a video that actually just solely focuses on the distance formula, and I'm going to leave a link in the description down below. Okay, so here we are. We have our distance formula. Now, why are these two related? Here's the key. We got to remember what a circle is. The idea of a circle is basically you have a center point and everything around it. Basically, this is an infinite amount of different points, right? It's all so close together that it basically looks like one drawn thing without any separation, but they're basically an infinite amount of points. The other key is that from these infinite amount of points, right, when you draw a line segment from that edge point to the center, they're all the same, right? That's the whole point of a circle, right? That's the definition. Now, each of these edge point to the center, right, that line segment is your radius. Hopefully you guys are familiar with that. If not, that's fine. That's basically the definition of radius. So distance from center to edge of the circle, all the same no matter what point you pick on the circle itself. So we can actually use the distance formula to find that. Quite simple. D stands for distance. Well, at this point we know the distance itself is just going to be the radius. So instead of D, we're just going to say this is R. Now, the rest of them is going to be a tad bit tricky, right? You have your x2 minus x1 squared plus y2 minus y1 squared, okay? Which is cool, but I mean, not the best. Here's the thing though. Remember that these are the change in the coordinates, and we know the change in the coordinate is dependent on what part of the circle you're picking. So in this case, x2 and y2, right, will depend on where you pick it. Whatever point you pick is going to have a different x2 and a y2. And since we want to generalize it, rather than just say x2 and y2, because we're going to end up using h and k, and you know it can get confusing if we leave the 2 there, we're just going to change it to x and y. So it's going to be r equals, and I'm going to keep our square root. Now the inside, rather than x2, let's just make sure this is x. And then we're going to minus x1 squared plus y minus y1 squared. So it's getting closer. Okay. Now remember, x1 and y1 is the other point. Well, the x and y is the generalized, basically, I guess you could say notation or variable, such that it doesn't matter which point we pick on the edge location, it's fine. This one, you can guess, since we're talking about the distance, right, or the radius, it's going to be these guys right here. So it's going to be r equals square root of x minus, instead of x1, we have a set point, which is going to be h, our center point right there. H squared plus y minus k. Well, let's just make it consistent, k squared, okay? Almost there. Now, this is not the formula that you're normally gonna see in relation to the circle, even though I feel like this is a lot better, right? what you're actually going to see is this. We square both sides, right? Let's just do this. Square both sides to get rid of the square root. So we have r squared equals x minus h squared plus y minus k squared. And that's your formula for a circle, where h comma k is center point. Hard to write down here, but point. Okay, here's your formula of a circle. And notice once again, even though, I mean, this is probably pretty easy to memorize, but if not, just know that it comes from the concept of distance formula. And the distance formula is just utilizing the definition of radius instead of just an arbitrary distance, and the distance from any of the edge points to the center. So there it is. So let's focus on how we're going to actually use this. All right, so let's look at this question really quickly. What is the formula for a circle on the origin with radius 3? Now, this is a fairly simple question. Maybe the vocabulary might be a little more inclined to make you guys confused, but other than that, fairly simple. Circle on the origin. Now, that's probably the biggest one. And from my experience, if we glance at this and don't realize what the origin means, then we're kind of confused. But origin usually in this case just means the point 0, 0, right? In a graph or a coordinate plane, basically, the origin is right here where the two axes cross, and usually that is 0, 0, okay? So basically, this entire problem, what is the formula for a circle on the origin with radius 3, is the idea of what is the formula for a circle that has 0, 0 as its center with radius 3. And here's the circle formula, so we can at least get a little more comfortable with it. Well, radius is going to be 3 squared, right? Equals x minus, well, since it's the origin, right, h is actually going to be 0 squared plus y minus, once again, 0 squared. So here we have is going to be 3 squared equals x squared plus y squared. Now here's where it gets a little tricky, right? Personally, for me, when I design problems or when I want, I guess, my students to learn the formula, I love it when they keep it like this, because this is clearly the radius itself, right? And then you have x squared plus y squared. But I've seen situations where if you keep it like this, they are marked incorrect based on the person who was grading it. So if worst comes to worst, make sure you guys complete this and just have it as 9 equals x squared plus y squared, even though I don't like it as much, because then all of a sudden the radius itself is not nearly as obvious as this guy right here. But this would be the formula. So of course the next one is a little more complicated because you don't have the origin where all the math is, I guess you could say, as nice. Here we have an actual center that they give you, right? Let the center be 2, 1 with the radius 5. And of course we're just going to use that formula again and plug it in. So technically we have 5 squared, right, equals, and we have x minus, our x coordinate is going to be 2 squared of the center, plus y minus 1 squared. Now, normally this would be fine, but the problem is that every now and then when you see this, they really want you to basically write everything out. That means, distribute all this, multiply together, and combine like terms and all that stuff. So that's what we're gonna do, just so we can get a feel for when you see a problem like this, what they expect. So of course right here we have 25, right, equals, and then x minus 2 times x minus 2. I'll just write it out right here, and then we can do the math really quickly, right? Plus y minus 1 times y minus 1. And I'm going to jump right down here, right? So let's, just to make it obvious, let's start right here, although that kind of killed some of the space, but all right, that's cool. So that's going to be 25, which is great, right? We didn't need to do much here. But this one, we're basically distributing right here, or FOIL, as some of you guys might be familiar with. What we have is going to be x squared minus 2x minus 2x plus 4. Okay, so that's this part right here. Let's just put a parentheses so we know that's this segment. All right, plus, and we're gonna, well, FOIL this guy as well, or distribute this guy as well, I'm getting confused. All right, there we go. Cool. That's going to be, what is it? Y squared minus y plus 1. Right there. Okay. Now we start combining like terms and everything would be nice and dandy. So here we have x squared minus 4x plus 4 plus y squared minus 2y, right, plus 1. And the last thing is these guys right here, we have to combine. So that's one common mistake if they want you to be completely, simplified in all ways and shapes and size, whatever. 25 equals x squared minus 4x plus y squared minus 2y, and then these guys combine to become plus 5. So this would be something you might potentially see. And so the next problem you guys can guess is we're going to give you something like this, and we got to convert it backwards to something like this. Okay, so let's begin. All right, so here we are. This kind of problem, how can we convert it back to the actual formula of a circle? The reason we would need to do that is because guess what? If they give you a problem like this and tell you to graph, not great. But if they give you something like this, then at least you're able to graph it. Because I mean, all you get is the center and the radius, and that's all you need, and you're good to go. But this one doesn't tell you much. But here's the thing. What can we do to actually convert this to that? The idea is that these are separated right here. You have your x, and then you have your y, and then some number. Now, these are quadratic, and in order to actually factor them out, we're going to use completing the square. And I've done a video on completing the square. You guys can sort of guess, right? I'm going to put a link in the description down below. But we're going to do completing the square with this one. Now, very quick, completing the square is basically you get what's in front of the variable with the single, I guess you could say, term. Instead of the square, just whatever is in the middle of a quadratic, or basically whatever number has the one variable, right? So we're going to look at this. What you're going to do is you're going to get the coefficient, you're going to divide it by 2 and multiply it by itself. So in this case, let's just look at the x part first. We have x squared plus 4x. And so this right here, the 4x, we're going to divide by 2, which is going to be 2, and times itself, it's going to be 4. So we're going to add 4 here. So let's just make it red here so you can see it, plus 4. But here's the thing. Numbers don't just come out of nowhere. When you change something, when you're adding numbers or subtracting numbers, because this is an equal sign, you have to do it on both sides to maintain the fact that they're equal. You can't just start adding numbers on one side and not messing with the other. There's no way they're equal, right? It's no different than if you say, for example, 2 plus 2 equals 4, which is great. We all know that. But then all of a sudden I go crazy and start adding 3 and adding, oh, that was a bad 3. That could have been 5, right? Well, let's just add 5. Add 7. And I don't do anything here, right? And all of a sudden you're saying 2 plus 2 plus 3 plus 5 plus 7 equals 4? No, doesn't make sense. Same logic here. If we decide to randomly add 4, because we're doing completing the square, right? We have to do it on the other side as well. So make sure that we have a plus 4 here. Now I'm going to continue. Here we have y squared minus 6y. And what I'm going to do is I'm going to get this middle term, or the term in front of just that one single variable, right? Negative 6. Divide by 2 is going to be a negative 3 multiplied by itself. So negative 3 times negative 3 is 9. So that's a positive 9. So I'm going to add 9 right here. Let's just keep it at red. Plus 9. That means, once again, on the other side, we have to add 9 as well. So this one's going to be 51 plus 4 plus 9. And now we have two different quadratics. Okay. With this, right, we can actually, I guess you could say, factor them out, right? We would have basically, and this is just to save us some time, x plus 2 squared, right? And this right here, we can factor it out. It's going to be y, what is that? You guys can guess, right? Minus 3 squared. There it is. And then make sure we have a plus sign here and a plus sign here. Just don't, from up here, don't forget it. There it is. Equals, and now we have 51 plus 9 plus 4. Well, 51 plus 9 is 60, plus 4 is 64. So we're almost there, right? At least we have our center. We can see that the center is going to be here and here. And then we have our radius. But this one is not in the format we really want, because remember, in the formula, it's radius squared. So basically we can rewrite this, or take the square root and try to figure out what it is. We know that 64 square root is going to be 8. So this is technically right here, 8 squared. All right, cool. Let's rewrite the formula. So we have 8 squared equals x plus 2 squared plus y minus 3 squared. Okay? What is our center? Our center is actually negative 2 comma 3. Why negative? Remember that in the formula it's actually subtracting h. Since this is a plus 2, the only way this works is basically you have a minus negative 2. That's why it's going to be a negative 2, and this one is a minus 3, which is fine because that means 3 itself is k. So it's going to be negative 2 comma 3. So here's our center. Our radius is right here, the 8. And just like that, right, we can basically graph this crazy looking equation into a standard circle. All right, so, well, there you have it, right? Pythagorean theorem gives you the distance formula. Now, distance formula gives you the circle formula. And in the future, circle formula actually does sort of give you the formula for ellipses, but it gets a little complicated. So I'm going to leave that in a future video. Hopefully this is helpful. If you can't remember this, that's entirely fine. Remember it's from the distance formula. And if you can't remember that, remember the Pythagorean theorem and how the distance formula is related. And just like that, 3 formula can be simplified to 1 formula, which is a squared plus b squared equals c squared, the one I recommend you to actually memorize. And then everything else is great. Just logically reason through it. Distance formula, remember radius is the distance from the center to the edge location or edge circle, whatever you want to call it, right? And that's where this circle formula comes from, right? Hopefully that clears some confusion, makes things a little easier. Thank you for watching this video. See you in the next one.